Have you ever thought about how a few simple lines of code can, well, scale up to build pretty much the entire modern world? We're going to talk about Python, the programming language that's basically hiding in plain sight, quietly powering just about everything you touch. So let me ask you this. What's the one thing that connects your daily Google search, the app you use to share photos, and, get this, the rovers exploring Mars? I know, it sounds like a riddle, right? But the answer is a shared language. They all rely on the exact same powerful, yet kind of surprisingly simple programming language. And yeah, you guessed it, the answer is Python. Its secret sauce, really its whole vibe, is captured perfectly in this one line from its guiding philosophy. Beautiful is better than ugly. Now, this isn't just about making things look pretty. It's a deep design principle that makes Python both incredibly powerful and uniquely easy to get into. Okay, so we know it's simple and beautiful, but what is Python really? What makes it tick? Let's, peel back the layers and break down the fundamentals. When its creator, Guido van Rossum, was designing Python way back in the late 80s, he had two really clear goals in mind: help developers get stuff done faster and make the code itself just effortless to read. You could almost say it's a language built for humans first and computers second. And believe me, this isn't some fleeting trend. Python has been evolving for decades. From its very first release back in '91 all the way to the modern powerhouse it is today, it is constantly adapted, it is improved, and it has built this massive, super dedicated community along the way. And this, right here, this gets to the very heart of why so many developers absolutely love Python. I mean, where other languages might use a bunch of complex symbols and really rigid rules, Python's syntax reads almost like plain English. Its design doesn't just encourage you to write clean code, it practically enforces it. So what does all that actually look like in practice? Let's dive into the real building blocks of the language. And don't worry, we're going to keep it simple. This simple line, this is often the very first thing anyone ever writes in a new programming language, and it just perfectly illustrates the whole Python philosophy. One intuitive command, and boom, the computer says hello. There's no complex setup, no confusing extra code. It's just a clear, direct instruction. Now here's something that's actually a really crucial difference. In most programming languages, how you space your code, the indentation, it's just for style. But in Python, it's the law. This super strict rule about spacing forces every single programmer to write clean, organized code, which makes it incredibly easy for huge teams to all work together on the same project. So how does Python actually store information? Well, the most basic way is with a list. It is exactly what it sounds like. It's a collection of items you can change, add to, or remove from whenever you want. You'd use this for anything that needs to be flexible, like players in a game or items in an online shopping cart, you name it. Then you've got something called a tuple. Now, it's a lot like a list, but with one huge difference. It's unchangeable. It's immutable. Once you create it, its contents are locked in stone. This is absolutely perfect for data you never want to change by accident, like, say, a set of fixed GPS coordinates for a rover on Mars. Next up is the set, and its superpower is all about ensuring uniqueness. You could give a set a list with a dozen duplicate items, and it will automatically and instantly just keep one of each. Think about it. If you're trying to track the unique visitors to a website, a set makes that ridiculously simple. And finally, we have one of Python's most powerful data tools, the dictionary. The analogy here is perfect. You have a unique key, like a word, that points to its value, the definition. This is exactly how you'd store a user's profile. The key name points to the value Alice, the key email points to their address. It's just fantastic for organizing related info. All right, so we've got our basic building blocks down. Now let's see how Python combines them to build these massive, complex applications. We're going to see how it turns simple lines of code into powerful, reusable blueprints. The main way Python does this is through a concept called object-oriented programming, or OOP for short. The big idea is to group related data and the functions that use that data together into a neat, self-contained object. And the blueprint you use to create these objects, that's called a class. Now, one of the most powerful ideas in OOP is inheritance. Let's say you create a general blueprint for a car. Then, later on, you want to create an electric car. Well, you don't have to start from scratch. You can just inherit all the features of the original car and then add what's new, like a battery and a charging function. It's just an incredibly efficient way to build things. So we've seen the philosophy, we've seen the mechanics. Now let's zoom back out from the code to the cosmos and connect all this to Python's incredible real-world impact and see how this one language truly powers so much of our world. This chart really shows just how versatile Python is. It's a huge player in web development, automation, scientific computing, but look at that massive slice of the pie. Data science and artificial intelligence? That's the one area where Python absolutely, positively reigns supreme. Seriously, it has become the de facto standard, the accepted, go-to language for pretty much all of AI and machine learning. Its simple syntax lets researchers focus on their complex algorithms, not on fighting with the code. And its massive ecosystem of free libraries gives them all the tools they need to build world-changing technology. So, let's just quickly recap the key takeaways here. Python's whole philosophy is that simple is way better than complex. Its structure is built on readable code and these really versatile data tools. Its ecosystem gives you a pre-built library for almost any task you can think of. And its impact? It's undeniable, making it the essential language for our data-driven world. At its core, Python is a tool for solving problems. It was literally designed to take complex ideas and make them simpler to build, which really just leaves one question for you. With a tool this powerful and this accessible in your hands, what complex problem are you going to solve?